All right, 1.9, we're going to split into two lessons. 1.9a, we're going to talk about percentiles, and it's a way to describe the location of a piece of data in a distribution. And then 1.9b, it's another way we do it. So first we're going to talk percentiles, though. So here's the scores for all 25 students in Mr. Pryor's stats class on their first test. The bold score is Jenny's 86. How did she perform this test relative to her classmates? Well, you want to figure out what is her percentile? How many people scored lower than her? That's what we're looking for. And so that's what we do is we add these up and divide by the total. It's really pretty simple. But we're finding where does she fit in relation to everyone else. Okay? So one way to describe Jenny's location in the distribution of test scores is to calculate her percentile. An individual's percentile is the percent of values in a distribution that are less than that individual's value. So if I look back at the dot plot and I count all the blue dots to the left or less than the red dot, which represents Jenny, there's 21 of them. So because 21 of the 25 observations, which is 84%, are below her score, Jenny is at the 84th percentile, okay, in her class test score distribution. So the way you interpret this, and you'll need to know this, is that 84% of the students in her class scored below Jenny's score. That's how you interpret. We do not say that Jenny is in the 84th percentile. There's no such thing as being in a percentile. You're at a percentile. So make sure you differentiate between the two. Now, there are some interesting graphs that can be made with percentiles. One of the most common starts with the frequency table for a quantitative variable and expands it to include a cumulative frequency and a cumulative relative frequency. A lot of words, so hang in there. A cumulative relative frequency graph plots a point corresponding to the cumulative relative frequency in each interval at the smallest value of the next interval, starting with a point that's at a height of 0 and the smallest value of the first. Consecutive points are then connected on a line segment to form a graph. And it's really complicated in words, but in pictures it's not bad. So here's a picture. So basically what we do, so this is ages of presidents at their inauguration. So we have age ranges here, okay, how many in that age range, and we divide it by 44 presidents to get our percentage, okay. So cumulative frequency, there's only 2 out of 44, so that's 4.5. And then for the next one, there's 7 in the next group. So if we add that 7 to 2, we get 9. 9 out of 44 gives us 20.5. So that's the next point on the graph. And then we keep adding. Add 13 to 9, we get 22. 22 out of 44 is 50%. Okay. And then we add, there's 12 in the next group, so we add 12 to 22, we get 34, and 34 out of 44 gives us 77%. Okay, and that helps us, we just build it this way. Now really what I want you to be able to do is read this thing. So that's what I'm going to focus on. A cumulative relative frequency graph can be used to describe the position of an individual within a distribution or to locate a specified percentile. Okay, that's what you need to be able to do. So let's try this. All right, so first, look at this. The dot plot shows the number of wins for each of the 30 Major League Baseball teams in the 2014 season. Find the percentile for the Boston Red Sox, who won 71 games. All right, so what I need to do is locate 71. Here's 71 right here in my box plot. Okay? So I need to count how many dots are below 71. So 1, 2, 3, 4, 5. So 5 out of 30 teams gives me 0.17. So I would say that is the 17th percentile. Okay, that's where the Boston Red Sox fall. Now another way they can ask a percentile question looks like this. The New York Yankees number of wins is at the 60th percentile. Interpret this value in context. And how many games did they win? All right, so they're at the 60th percentile. So the first thing it says is to interpret the value in context. Let's do that. We would say the New York Yankees won more games than 60 of the 30 teams in the 2014. Now, second part of the question, how many games did they win? Well, to figure this part out, we take what we know about percentages. Okay, if it's a 60th percentile, we do 0.6 times our 30 teams, and we get 18. All right? So, since we know it's lower than, we start at the bottom and we count up 18 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right here. So 85 games. That's how many they won. So then we would say the Yankees won. Alright, that's how you deal with percentiles using a dot plot. Now, let's look at one of those frequency graphs. The following is a cumulative relative frequency graph of the amount spent by the sample of 50 grocery shoppers at a store. Okay, so what I want you to notice about this graph is that on the y-axis are the percents. Okay, these are the percents. So if it's asking you what's at a certain percentile, you start here and you work your way down, because down here is the amount. Oops, amount spent, right? So you got to read the question really carefully to know where to start, okay? So A says, what is the percentile for the shopper who spent $19.50? So I'm starting with dollars and I'm going to percentages, right? So I'm going to start my answer at $19.50. Well, here's $19.50 right there. So I would make a little dotted line till it hits my curve, and then bump it over till I find what percentile that is. What does that line up to? Well, probably, I would guess, the 25th percentile. Now, it's approximate. It's not perfect. So if you said 22nd percentile, you'd be fine. Okay. Now, B says, estimate and interpret the 80th percentile of this distribution. So 80th percentile, we're starting with the percentile. So I have to start with the percent and draw my line over to the curve right here and see where it lands me. Okay, that landed me at $50. All right, so we would say the 80th percentile is about $50 spent. All right, now interpret, we would say about 80% of shoppers spent less than. Okay, so that's how you interpret a percentile. So we're going to do a little more practice with this in class, but I want to give you just a few examples to start you with as we talk about percentiles.